By the end of this video, I'm hoping to show you how to apply the use of fieldwork materials from an unfamiliar context, how to apply knowledge and understanding to interpret, analyse and evaluate information and issues related to geographical inquiry, and how to select, adapt and use a variety of skills and techniques to investigate questions and issues and communicate findings in relation to that geographical inquiry. I'm going to be working through some pages in a booklet that I've produced that is available at the link in the description, or if you're watching this via Lutterworth High School's EduLink homework, it is attached for you there. So firstly, I want to talk very briefly through some of the statistical skills, starting with quartiles and interquartile ranges. This is something that those of you who have studied further maths or statistics will be familiar with. Quartiles are the values that divide a list of numbers into 4 equal quarters. We end up with our lower quartile, our median, as the middle value, and our upper quartile. We're then able to calculate the interquartile range, which is the difference between that upper and lower quartile. In this case, the upper quartile is 23 and the lower quartile is 8. So the interquartile range is 23 take away 8, which gives us 15. Another skill that is involving statistics is that of calculating the percentage increase and decrease in a value. For example, number of robins in a woodland area are counted over 2 different months. In December 15, robins were counted. In January, 23 robins were counted. What is the percentage increase of robins in the woodland? We need to use this calculation. Percentage increase equals the increase divided by the original number times by 100. So firstly, we need the difference between the two numbers. That's 8. So we're going to take 8 as our increase and divide it by 15, which is our original number. We then multiply that by 100, which gives us 53.3. So the percentage increase of robins found in this woodland is 53.3%. To do the decrease, we do exactly the same thing, but this time we're calculating the difference as the decrease instead. Here the number of robins in woodland in February and March are counted. In February 22 robins were counted, in March 12 robins were counted. The percentage of decrease, the difference between the two numbers this time is 10. So 10 is our decrease, 22 is our original number. 10 divided by 22 times by 100 gives us 45.4. The percentage decrease of robins in the woodland is 45.4. Both of those formulas are ones that students are expected to know and be able to use in the Paper 3 exam. Next we come on to scatter graphs and how we use those to interpolate and extrapolate information. Scatter graphs allow us to show the relationship between two sets of data. For example, the number of tourists and the number of tourist facilities, or weight against height within a population. We can use a line of best fit or trend line to the scatter graph to show the relationship between the two variables. When we draw a line of best fit or trend line, it's important that we try and plot that through as many points as possible and keep an even number of points on each side of the line. Where those points lie very close to the line of best fit on the scatter graph, we say that is a strong correlation. That means the two variables are strongly related to one another. One causes changes to the other is one conclusion that can be drawn. A weak correlation is when the points lie far away from the line of best fit. In this case, the two variables are not necessarily related or not necessarily causing change to one another. By using our line of best fit, we're able to extrapolate trends and interpolate trends. Interpolation is where we look for a value that we haven't plotted within the data set and use that line of best fit to estimate the other value. So we might know somebody's weight but not their height. By using the line of best fit, we're able to make a judgment about how tall that person may be. Similarly, we can extrapolate from those data. Extrapolation may provide uncertain results, as it's based on extending the line of best fit beyond the known set of data. So this is for estimating different values. And again, let's say we have somebody that weighs more than any of the data we've collected. We can extend our line of best fit upwards to extrapolate from that trend. One final part of this statistical analysis we can do is known as the Spearman's rank correlation coefficient. Spearman's rank uses a statistical test to determine the strength of a relationship between two sets of data. So having plotted our scatter graph, we can put a number on the value to tell us how well related together those two values are. Spearman's rank gives an answer between -1, a negative correlation, where an increase in one value causes the other to decrease, and +1, a perfect positive correlation with a strong link where one positive change causes a positive change in the other value. A value of 0 means there is no correlation between those two data sets. For example, if Spearman's rank was 0.8, it's close to +1, so the link is strong, and it's possible to say those two sets of data are linked and increase together. If it was -0.8, it's possible to say these data are linked, and as one increases, the other decreases. If there's no relationship, a value close to 0 would be the one that is arrived at. The next section of what I'd like to talk about is the inquiry process. As we study fieldwork, the inquiry process is really important, and students are expected to understand the entirety of the inquiry process from start to finish. It's broken down by the exam board into 6 inquiry strands. Firstly, developing a suitable question for geographical inquiry. Students are expected to understand why a hypothesis is selected, the geographical theory and concepts underpinning an inquiry, appropriate primary and secondary data sources and how to determine the location for fieldwork, and the potential risks of human and physical fieldwork and how these risks can be reduced. Secondly, selecting, measuring and recording data appropriate to the chosen inquiry. Students need to understand the difference between primary and secondary data, identify and select appropriate data to use, measure and record data using different sampling methods, and describe and justify those data collection methods and the choices that they have made. Next, students must select appropriate ways of processing and presenting their data. There's a range of visual, graphical and cartographic methods that can be used that I will go through briefly later. The selection and accurate use of those methods and how they can be described, explained and adapted for different uses. We then come to section 4, describing, analysing and explaining fieldwork data. Students are expected to be able to describe, analyse and explain their results from fieldwork. Establish links between data sets where some of those scatter plots and correlation analyses that we've just looked at may become useful. Appropriate statistical techniques, for example, deployment of Spearman's rank. The identification of anomalies in fieldwork data. Anomalies meaning those data that do not fit a pattern. That doesn't mean they're invalid, but that is something that must be explained. Section 5 involves reaching conclusions, drawing those evidence conclusions in relation to the original aims of the inquiry. Are students able to answer the key question in relation to that inquiry? And finally, at number 6, an evaluation of the geographical inquiry. Identifying problems with data collection, limitations of the data that's being collected, suggestions for other data that may be useful, and the extent to which conclusions were reliable. These stems may well form part of a 6 or 9 mark question in the fieldwork section of paper 3. It is important that students are aware of the ways in which their fieldwork had strengths but also had weaknesses, and approaches that they could take should that fieldwork be collected again in future. As we move towards collecting data, we start to consider things like sampling strategies. There are 3 sampling strategies that you may have used with your fieldwork data collection: random, systematic, and stratified sampling. Random samples are collected at random to avoid researcher bias in the choice of a sample. A systematic sample works in a system to collect data at regular intervals, and a stratified sample deliberately introduces some bias to ensure the sample matches the aims of the inquiry and allows that data collection to answer the key question. That may involve selecting distinct study areas in the area to be studied. For example, if investigating a country park, as students at Lutterworth High School did in Lutterworth, then looking at different areas that have been managed in different ways is an important part of the data collection. An example of systematic sampling would be placing a quadrat, for example, every 30 paces or at every groin. And finally, a random sample may involve rolling a dice to select the number of people before approaching somebody to ask questions as part of a questionnaire. I would encourage you to perhaps screenshot this page and use it as a task to help you recognise where sampling was used in your fieldwork data collection. You could also suggest the benefits of each strategy later on. When data is collected, it will vary between doing physical and human fieldwork. A pedestrian count is appropriate human data collection, but would not be appropriate in the physical environment, where sediment analysis of beach material may be more appropriate. Data collection methods may also vary depending on your area of inquiry. For example, if studying the coast, you might measure beach profiles, whereas for rivers, you might measure velocity. Both of those being, of course, examples of physical fieldwork. There are many data collection techniques, and you need to be aware of a variety of these, but in particular the ones that you have used in your fieldwork investigations. Some methods produce numerical data, whilst others produce descriptive information. These are known as quantitative and qualitative methods. Qualitative data may require specialist equipment, may involve a measurement being taken, and produces numerical data. Qualitative data can record the setting and use of equipment, but is subjective. They require judgments by the data collector and produces descriptive data, writing, sketches and photographs. It's worth noting here that the labels on this table are actually inaccurate. That should be the other way round. Quantitative data is counted. You're presented with a quantity that you can use. Qualitative data is descriptive. It tells you about its qualities. The next activity that you could do is to select the data collection techniques that you have used and explain how it is used as part of your fieldwork. A list of methods includes questionnaires, pedestrian flow counts, environmental quality surveys, environmental impact surveys, land use surveys or transects, diversity indexes, mental maps, perception analysis. For coasts, you may use beach profiles, infiltration rates and sediment analyses, and for rivers, cross-sections, velocity and sediment analysis. As an example, an urban land use transect can be used for human fieldwork. This uses a classification key based on land use type. You walk the transect route and gradually build up information on a base map, adding colours and codes from the key. It aims to investigate land use patterns and change over time, to identify issues concerning the management of the urban area, to undertake a study of the function of a town or of different parts of a town or city, or compare the function of different towns and cities. Mapping large areas can be time-consuming and labour-intensive. Group work is a good idea. A suitable sampling strategy should be devised to reduce bias in land use surveys. Obtaining site maps, especially historical ones, can be difficult, and there may be a cost involved. Subjectivity is inevitable when classifying land use, and errors can sometimes be made in judging the age and style of buildings. There is a model that you could use to help you, support you in doing a similar analysis of the data collection methods that you have used in your own investigation. We'll now move on to have a look at risk assessment as part of your fieldwork. A typical task for risk assessment would involve annotating an image, so we will shortly model that. But firstly, let's consider the purpose of risk assessment. All fieldwork has associated risks. Risk assessments help us understand that risk and avoid potentially dangerous situations. For example, walking alongside fast-flowing streams or carrying expensive equipment through areas of high crime. A good risk assessment will also consider what to do if a difficult situation arises. Your teachers will have completed risk assessments of your fieldwork, but you need to be aware of the risks that you faced and how to go about addressing them. Here we have a photograph of some students collecting data next to open water. So immediately we should be able to identify some examples of risk that we need to assess. I'm going to annotate this picture by putting specific labels onto the image to show what hazards are presented first of all. For example, the open water. This presents a risk of drowning. We can see there is a cow in the image. There is a risk associated with interacting with livestock. And there may be a risk of something like trampling. Now, identifying those hazards is only one part of this task and only one part of risk assessment. The next phase is to consider what we would do to address that risk. So I'm going to do a second arrow for each of these and suggest what to do to reduce that risk. For the open water and the risk of drowning, we could say keep away from the banks. In this case, the students are investigating something on the land. They don't need to enter the water. With the livestock, we're going to avoid approaching that livestock. Startling those animals. These are basic things that we can do to keep ourselves safe. This is a typical type of 3-mark question that you may be presented with as part of the Paper 3 exam. What would you do to manage the risks that you faced in this fieldwork? I'm now going to show you a second image. This time it is of a city centre, Chester city centre in fact. Again, you could screenshot this and have a go at annotating it to consider some of the hazards that may be presented to you completing fieldwork. You might like to consider traffic, construction work, interactions with members of the public, even the weather. When annotating these on your image, make sure that you are linking very specifically to those features using an arrow. The next part of our inquiry process is presenting data. Data needs to be presented in ways that make it easy to understand. However, there are different types of data, which means different presentation techniques are needed. You're likely to be questions on data presentation in the unfamiliar fieldwork section of Paper 3, so you need to know why different data presentation methods are used. I'd advise you to download the document and have a go at describing each of these data presentation methods, explaining how they're used, and evaluating the strengths and weaknesses of each technique. I'll quickly go over them now, but there's more information to be found on resources like BBC Bitesize. Firstly, we can use field sketches to draw an image of what we can see. It allows us to examine the human and physical features of a landscape, or we could even repeat this over time or compare it to photographs. It's a quick method. It allows us to see what's important and remove elements that are not desirable in a way that we can't do with a photograph, but it is subject to those judgments, so may not present a full picture of what we can see. Two of the most basic ways of presenting quantitative data are line charts and bar charts. Bar charts are useful where we need to show different categories of information, perhaps based around somebody's age or gender. Line charts are useful to show change over time. When doing both of these, it's important that the scales are proportional and appropriate so that we don't provide bias and put bias into our data. Pie charts are used to show the proportion of a whole. They can be great for breaking down a population or breaking down a total score to show its constituent parts. Pictograms are often used to show pictorially and represent a percentage where we're comparing perhaps different methods of transport. We might have a picture representing cars, buses and trains, and the length of that image or the number of them that there are will represent the value. They can be tricky to read, but they're very easy to present that information in a way that doesn't rely us to use text. A histogram looks much like a bar chart, but is used where we have continuous data. Each class has an equal interval, and it allows us to look at the trends and patterns within that data. So it can work a little bit like a line graph, a little bit like a bar chart, but they have their own use for things like looking at the spread in a range of data across continuous categories. That might be something like a population pyramid, for example, you could interpret as a histogram. Divided bars allow us to, much like a bar chart, show us categories of data. But whereas a bar chart only allows us to show one category, with a divided bar we can break up those categories into subcategories. So we might have a number of men and women and be able to divide that up by age group. We may have a number of people who have responded to a survey who are from different backgrounds, but we can break up their responses, strongly agree, disagree, etc. We've already talked about scatter graphs, which can be used to show the relationships between two disparate pieces of data. Population pyramids I've mentioned as a way of showing the breakdown and makeup of a population in terms of its gender ratio and by age. And then we come on to some of the different types of maps that we can use. Choropleth maps are used to show numerical data by using shades of colour for different areas. Generally speaking, the darker the area, the higher the value. Isolines on maps will be most familiar to you from contours on ordnance survey maps. They show lines of equal value, so can be used to show things like the temperature of an area or the height of terrain. Isolines can never cross, because if they did so, then they would no longer represent lines of equal value. Dot maps are probably the simplest type of map and represent a point for each value. Often these are used to show population density, with each dot representing a certain number of people. Desire line maps show the links between different places. Often these are used by airports or airlines to show their connections to different parts of the world. Proportional symbol maps show their values by using circles or squares of different sizes. Interestingly, these could also be combined with pie charts to show different breakdowns of those values. And finally, a flowline map is used to show the relationship between two places and the strength of that relationship. Typically, these are used to show things like migration, how many people have gone from one place to another, with the thicker bars representing higher numbers of people. We're now going to move on to look at some practice exam questions from paper 3. This will be the final part of our video, and will allow us to consider some of the question types that are presented in paper 3. Firstly, we're asked to study figure 1, a photograph of Stratford Shopping Centre in East London, and figure 2, a photograph of a Corrian stream in the Lake District National Park. It's worth mentioning that the fieldwork questions will only ever refer to fieldwork that could have been done based on the links to the specification of AQA GCSE Geography. So you would never be asked questions which would require you to have studied something beyond the specification. We're asked to suggest one question that could form the basis of a human geography inquiry in the environment shown in figure 1. So we're looking at the photograph of Stratford Shopping Centre. Anything about the character of the place. We could talk about transport because we've got a coach. We could talk about regeneration because of the modern building. So any question where we are thinking about those ideas would be valid. So something like, is Stratford a popular location for shoppers from outside of East London, would be an appropriate question. Similarly, we could flip that round. How is the character of East London affected by Stratford Shopping Centre? Any question that you were to write that would be linked to the image or the prompt above it would be seen as valid. So either of those questions would pick up the 1 mark. Next, we're asked to outline a primary data collection technique that could be used in the environment shown in figure 1 to help answer this question. So, firstly, we're asked about a primary data collection technique. That means data that we ourselves are collecting as part of our fieldwork, not data that is collected by somebody else. Again, we're looking at figure number 1. So, we could use questionnaires to ask local people about their views of the shopping centre or to find out where they're from. And that would allow us to pick up our mark, to say something that would allow us to answer this question. So I'm going to say that questionnaires could be used to ask people how far they travelled to the shopping centre. That would be valid for either of these questions, of course. But let's say how this would be useful and how this would link back to our question. This would be useful because local people may use the shopping centre and feel part of the community of East London. Again, thinking about the location that we're given in the question. We're then asked to present information about how we would present the information and what we would do with those data that we have collected. So we could say these questions, of course, and we could perhaps, based on the questionnaire, answers to questions about how far people have travelled, could be presented in a bar chart. Simple bar chart with each category representing how far people have travelled. Finally, we're asked to explain how one possible risk of collecting data in the environment could be addressed. We need to make sure that we present that risk, and then after that say how we're going to deal with it. This phrase, could be addressed, means what do we do to mitigate that risk and keep ourselves safe. So let's model an answer. So the answer then, one possible risk could be traffic, which could lead to harm if somebody were to be hit by a vehicle. This could be addressed by following the Green Cross Code and wearing high visibility clothing to ensure visibility. This prevents road injury because drivers will be more aware of my presence, so better able to adjust their driving or take avoiding action. By being predictable in my use of the Green Cross Code, I will not present a hazard to road users, so I'm kept safer by using crossings. My advice now for you would be to have a go at these questions that are based on figure 2, based on that image of the countryside, the Corrigan Stream in the Lake District National Park. Again, take a screenshot or have a look at this and on the resources that we've provided. I hope overall this has been a useful video to help highlight some of the issues associated with the fieldwork skills element of paper 3. All that remains is for me to wish you the very best of luck for going into your examination, and wish you a wonderful summer holiday by the time you get there, and a long, well-deserved rest. Take care. Goodbye.